So we are going to talk about finding roots of polynomials, and we'll sort of just go through an example here, and we'll be talking about a number of these pieces throughout the next couple days. And so we will use our graphing calculator to help guide us here a little bit. And so we're going to start with what's called the rational roots theorem, which I think you've at least seen pieces of in Honors Algebra 2. And so we're going to look at this last number, the constant, and we're going to look at the lead coefficient. And we'll sort of talk about why this works in class, but for now the procedure is we're going to make this list of what we call p's. And p's will be the factors of the constant, so things that go into 20 evenly. So we'll have 1, 2, 4, 5, 10, and 20, right? So 1 and 20, 2 and 10, 4 and 5. I think I hit them all. And then Q will be the factors of the lead coefficient, so the number in front of the highest power. And so in this case, that's just 2. And we're now going to make all our fractions of the form P over Q. And they can be positive or negative. And so basically, we're going to have all these numbers with 1 on the bottom. So plus or minus 1, plus or minus 2, plus or minus 4, and so on. And then we're going to also have all of them over 2, but you can sort of watch and pay attention and you can save yourself some writing. So I'm going to have 1 over 2, so that means 1/2 is a possible solution. 2 over 2 would be 1, so I don't need to write that. 4 over 2 would be 2, so I don't need to write that. But 5 over 2 is a new one. 10 over 2 would be 5. I don't need to list that. 20 over 2 would be 10, which I've already listed, so I don't need to list that. So if there are real rational solutions, so solutions that don't have I in them, that don't have square roots in them, they have to be on this list. So this is going to help me out when I look at my graphing calculator, which I'm going to do next. I'm going to go to y equals and enter in that function, so 2x to the 4th minus 15x to the 3rd plus 34x squared minus 19x minus 20. And typically I would just start with Zoom standard. We might have to adjust that based on what we're seeing. And we're looking for x-intercepts. So as I look at this and then I'm comparing it to my list, and so it looks like there's one around here, which is 1, 2, 3, 4. That seems promising because it's on my list up here. And then this one is between 0 and -1. Because I have my list in mind, I don't have to bother checking on my calculator. Well, is it 1/4, -1/4, -1/3? Where is it? If it's anything that works, it's going to have to be -1/2. That's the only fraction between 0 and -1 that's on my list. And so I have sort of 2 potential solutions based on my calculator and my list, 4 and -1/2. And so the way I'm going to check those now is with synthetic division. And so I'm going to take my coefficients, if I can see these here. So 2, -15, +34, -19, and -20. And I think that 4 is a solution. And so x minus 4 would be the factor. And so I put the potential solution out here in front, 4. And then I bring down the 2, multiply, add, multiply, add, multiply, add, and I'm feeling good now because at the end I get remainder 0. And so that means I have successfully factored my polynomial. And so x minus 4 is one factor, and this gives me my other factor, the quotient. So 2x cubed minus 7x squared plus 6x plus 5. All right? And so I've made some progress. I know what one solution is. And now I'm down to a cubic. And so I could repeat this whole process. I could do my P's and Q's. I could regraph this. But of course, this came from my original equation. There's not going to be any new information there really. So I thought -1/2 was a solution. And so I'm going to check to see if -1/2 is a solution. And the catch is, don't go back to your original equation. Go to this quotient that we just figured out. So I'm going to bring down the 2, multiply, and add, multiply, and add, multiply, and add, and sure enough, I get a remainder of 0. And so now I have been successful in getting another factor. So I have x minus 4, x plus 1/2, right? If negative 1/2 is the solution, x plus 1/2 is the factor. And so then 2x squared minus 8x plus 10. And so now the question is, what are we going to do with this? And there might be some other answers, but they aren't showing up on our graph. So we figure probably these have non-real solutions. And so I'm just going to go to my calculator and pull up, hopefully this one has the quadratic formula. And so I'm going to check this one out. So I'm going to have 2, -8, and 10. And there are two roots, 2 plus I and 2 minus I. And so in the end, I have 4 solutions. So let's write them down over here. So I have x equals 4, x equals -1/2, and x equals 2 plus I, and x equals 2 minus I that I got from the quadratic formula. And so, as we'll talk about in class, this should not be a huge shock. I got 4 solutions, right? It was a 4th degree polynomial. So using our calculator, using synthetic division, using these P's and Q's, I'm able to pretty quickly get those 4 solutions, those 4 zeros to the equation.